This is going to be one of the most comprehensive chemistry class or more concept you ever come across on YouTube. In this class, I want to walk you through what is more concept, so I'll be able to get an idea what more concept is all about. Then after that, I want to walk you through the various formulas you can use in calculating more concept problem. I'm going to show you how to derive some. I'm going to show you some so that you know this formula. By the time you send to the exam, when you see any more concept problem, you should be able to know the formula to apply. Then the last thing you want to do here, which is the major point of this class, is solving variety of problem using this formula, teaching you the type of the type of question I want to see and the formula you want to apply. It's going to be a massive class, so it's going to be a lengthy class because I really want to dive deep down so that you can be able to solve more concepts. Now, I want to assure you one thing here. By the time you finish watching this video, then you should be able to be fully grounded when it comes to more concept calculation. Whether you're a beginner or you are being in the field of chemistry before, then this video is going to be of help to you. Now, one thing I want to understand here is that more concept is a fundamental aspect of chemistry calculation. So that is why you have to take it serious. If you can master this more concept calculation, then every other chemistry calculation will be an easy step for you. Do you understand? So this is just what the fundamental. So buckle your seatbelt, take down your writing material. Let's dive into the game of chemistry. Please consider subscribe if you have not done that. Please give this video a like, and I'm going to give you some practice problem as you walk along in this video. Let's get into it. So the first thing, what is mole concept? Mole concept is a fundamental concept in chemistry that relates the amount of a substance to its mass and the numbers of entities like the atoms, molecules, or ions in that substance. So that is what is the definition of mole. And mole concept is one of the is a unit used in chemistry. So now the next you want to look at is various formulas to solve mole concept, which is most important. So the first one here, mole. The first formula I want to take here is that mole equals what? Mass over what? Molar mass. Idea. So this is what first formula into what? No, mole equals what? Mass over what? Molar mass. So when the question is being given to you, calculate the mole of a substance, and you have been given the mass, they can calculate what the molar mass of that compound. Just as so that is what the first one. The next one is what? Mole equals what? Numbers of atoms or molecule or slash what? Molecule over what? The Avogadro's constant, which is what? Is the Na. Now where I see Na is what? Is Avogadro's constant, which is 6.02 exponential 23. Very important. So the next one is what? Is mole. Mole equals what? Volume of substance. Volume of substance can be volume of the atom, volume of the molecule. Do you understand? Volume of substance over what? Volume at STP. Idea. And volume at STP, volume at STP is always equal to 2.4 dm3. Do you understand? So if examiner they gave us the volume of the substance as what? Dm cube. Now we are going to use formula. Don't worry, I'm going to show you how you can solve various problems using this formula. Now the next one we are going to look at here is concentration. Concentration. That is where you are solving concentration. Concentration is equals to what? Is equals to what? Mole over volume. And the volume must be what? In dm cube or liter. Do you understand? Now, dm cube is also the same thing as liter. So 1 dm cube is also the same as 1 what? Liter. Just that. And 1 dm cube is what? Is 1000 cl cube. This is that. Now, cm cube is also now what? Milliliter. So 1 dm cube also the same as liter. So you can either use dm cube or liter interchangeably. Just 1 dm cube is always equal to 1000 centimeter cube. And this centimeter cube is also the same thing as mil. Because say 1 liter equals to what? 1000 what? Mil. Now, liter and dm cube are the same. Milliliter and what cm cube are the same. These are things you need to pay close attention to. So if I should write this place here, because I'm just giving you what the unit of conversion here. Now, if I should make mole the subject of formula, so mole here I can say mole equals to what? Concentration times what? Volume. Remember, the volume must be what? In dm. Hope you understand now. So this is first formula, this is what the second formula, this is what the third formula, this what is the fourth formula. Mole equals to concentration times of volume. Do you see that? So that is what the key formula we can what make use of. But understand that we can, so you can equate everything here. We can just say mole equals to what? Mass over what? Molar mass, right? Equals to, is the same to here, numbers of atoms, numbers of atoms over what? Na, right? Can you see that? Next is what? Volume of substance over what? Volume at STP equals to volume of what? Substance over volume at what? STP, right? Equals to, which is what? Concentration times what? Volume. Concentration, let's say concentration times what? Volume. Do you see that? So these are the various formulas you need to apply when you are solving problem. Very important. Just 1, 2, 3, 4. So we can break them down. Now, what you want to understand here is that this concentration here is what? Is mole per dm cube. So the unit of this concentration here is what? Is mole per what? Dm cube, or mole per what? Per liter. The volume is what? Is what? Dm cube. So these are the various formula you can apply when solving mole concept. So we're not getting to the various questions now. Let's start solving some practical problem now. Do you understand? If you're following this class here, leave a comment section that you are following this class. Please kindly give this video a like, and if you're not subscribed, kindly hit the subscribe button so that other content like this you will not miss out on that. So now let's start solving question using this formula, so that you get to understand how to solve problem with these formulas. So let's start solving problem. So these are my various formulas in solving mole concept. Now let's say the first two set of questions. They'll do that till you get to probably 20 questions. So it's going to be a massive question, like massive calculation, so that you're able to understand the concept. Do you understand? If I finish solving this one here, I'm going to like do adjustments so I can solve on your own. So let's look at the first one. Say, how many molecules are there in 5.6 dm cube of ammonia at STP? Very important. How many molecules? Now look at all the formulas here. The first one to do here, numbers. Therefore, write out all the formulas. So write out all the parameters, the values given to us. Then what they say we should calculate, as easy as that. So it's that how many molecules there is numbers of molecules. We are being asked to calculate numbers of molecules. Very important. Numbers of molecules. Do what they say you should look for, right? How many molecules are there in 5.6 dm cube of ammonia? Now, they gave us volume of the compound, volume of ammonia. So, volume of what? Of NH3 is being given to be what? To be what? 5.6 dm cube. They say at STP. At what? STP. So, how do you calculate the question here? Remember, mole equals to what? Mass per molar mass. They did say you should calculate mole. So we are not using that. We are not asked to calculate mole. So this one is out of it. Now, mass over molar mass. There's no mass here. They did talk about molar mass. So we are not using this guy. Do you see that? Now the next thing is what? Is numbers of atoms. Remember, I gave this formula here. It can either be atom or molecule. Do you understand? Atom or what? Molecule. So numbers of atoms slash molecule over 6.02 exponential 23. Do you see that? So it is saying that we are going to use this one here because numbers of molecule is here. So going to be numbers of what? Of molecule over what? Over 6.02 exponential what? 23, which is called the Avogadro's constant, right? Now essentially what they give us volume of NH3 to be this one here. So volume of NH3 we call volume of the substance. So it is saying that after writing this one here, the next one I want to use is this guy here equals to volume of NH3 at ST. Remember, this one means what at ST, which called 22.4 dm cube. As easy as that. So once you know this one here, look at the question, pick out what you have been given and what they say you calculate. From this question here, they say you will calculate numbers of molecules, which is this. They gave us volume of NH3, which is this one here at STP. Do you see that? So this is what you are looking for. This is what you are looking for. So the goal here is to make this guy the subject of formula. This is that if you make this guy the subject of formula here, it's going to be what? Number, because this is what I'm calculating. So it's going to be numbers of molecule, numbers of molecule equals to this times this divided by this, right? So it's going to be volume of what? Of NH3 times 6.02 exponential 23 over what? Volume at test, which is what? 22.4 dm cube, right? So what I want to do here is what? Impute our value here, impute this one here. So if I should impute this one here, it's going to be 5.6 dm cube times what? 6.02 exponential what? 23 over 22.4 dm cube, right? This cancel out this here. So here it's going to be 5.6 times 6.02 exponential 23 divided by 22.4. So the answer is what? 1.505 exponential what? 23 what? Molecule. It's going to be what? Molecule. As easy as that. Do you understand? So it depends on the question. The question will tell you what the formula to what to apply. Do you understand? So from the question here, they say well, numbers of molecule, right? That's why you pick out this one here. Now they give us volume of what NH3 at STP to this one here, right? So that's why we use this one here. So make this guy a solid formula here. Do what I want to get as easy as that. Now let me give you what you're going to try. Now let us say that let's remove this one here. Let us say is now let us say we have what in there in 2.85 dm cube of now let us say is what CO2 at SP. So go ahead, pause the video and solve this one for me. Leave it at the comment section, please. This class is an interactive class. Do you understand? So go ahead and use this formula here, what I've done here, and solve it for me. Then say question 1. This is the answer. I will check it if you are correct or not, right? So now let me to what question 2. Let me to what question 2. Now, if you look at question 2 here, it says that what is the mass of zinc tetraoxosulfate 6? So zinc tetraoxosulfate 6, which is this guy here. Do you understand? So that is why as a chemist, you need to know how to understand compounds, the naming and the formulas. So zinc tetraoxosulfate 6, which is this here. Now, so they say what mass. So let's say solution. Let's write out what will be given. So they say what you will calculate mass of zinc tetraoxosulfate 6, right? So it will be mass of zinc tetraoxosulfate 6. This is what they say you will look for, right? Which is required to make. Now they give us volume of the compound. Volume is equals to what? Of 400 cm cube. Now concentration is equals to what? 4.0 molarity. So how are we going to solve this question now? How are we going to solve this question? Please pay close attention here. Now remember, the volume must be converted. Now when you say cm cube, when I talk about concentration, because molarity, when we talk about molarity, we talk about capital letter M, which is called molarity. What you want to understand here is that molarity is equal to mole over what? Volume. Mole over what? Volume. Which also the same thing as concentration, right? As what? Concentration. Now, this volume must be what? In dm3. So now, when I use something like this here, cm3, just divide by what? 1000. If you divide it by 1000, so if you divide it by 1000, you have to get 0.4 dm3. Fine. So these are all our what? These are all our parameters here. So now let's look at the formula we have to use here. Now they say we should calculate mass. Mass, of course, this is mass. So that we are using mass over what? Molar mass, right? Because it's all about mass of zinc SO4, right? So which is going to be mass over what? Molar mass. Can you see that? Equals to. Now they are talking about concentration, right? Which concentration what? Volume. So you know this one here, we know this one here. So going to be concentration times what? Volume. As easy as that. So but the only thing I want to do here is to calculate the molar mass of this guy. Calculate the molar mass of zinc. So how do you calculate the molar mass of zinc? You have to what? Know the atomic mass of zinc, atomic mass of sulfur, atomic mass of what? Oxygen. So now we have to calculate what? The molar mass of zinc. Now, why do we calculate the molar mass of zinc here? Now, they say for the mass, right, over what? Molar mass equals to what? Concentration, which we are be given, times the volume. Can you see that? So the only thing we want to do here is we'll calculate the molar mass of what? Of this guy here. So molar mass of zinc sulfate equals to. Now, if not that you still have issues of calculating molar mass of a compound, I've done a complete video of calculating the molar mass of compound and the percentage composition. You understand? So the link will be at the description below so that you can check out that video probably when you finish watching this video. Now, what is the atomic mass of zinc? The atomic mass of zinc is what? 65.39. Now, in some questions, it will be given to you, but in some questions, it might be given to you like something like this here. So that's why you have to know them. 65.39. So the atomic mass of this zinc here is called 65.39. So it's going to be 65.39 times 1. Why do I multiply by 1? This one is because of what? Zinc is one atom of zinc. Do you understand? And the atomic mass is what? 65.39 plus sulfur itself is what? Is 32. So it's going to be 32 times 1. Can you see that? Plus oxygen is 16. Can you see that? Oxygen is 16. So it's going to be 16 times 4. So if you should do your calculation, let me just quickly do the calculation here. Here we have 161.39. So the molar mass of what? Of zinc sulfate is what? Is 161.39 gram per what? Per mole. This is that. So now once we have got to what? Our molar mass here, the goal is to make mass the subject of formula. Just see that making what? Mass the subject formula here. Let me wipe this place out. Let me know if solve it in this place here. So what are you going to get here? So if I should what? Make mass the subject of formula. Remember here is 1, right? Mass for molar mass equals to concentration times what? Volume. When it cross multiply, it's going to be what? Mass equals to what? Molar mass times concentration times what? Volume, right? So we're going to be what? 161.39, right? Times concentration is what? Concentration is what? 0.4. No, concentration is what? 4.0. 4.0 times. Now, what is the volume? Volume is 0.4, right? 0.4 dm3. So times 4.0 times 0.4. Here we have the answer. The mass equals to what? 258.224 gram. This is what is the answer, right? Now, what about if I should change values? Now let us say here is what 600 and here we have 6.5 molarity, right? What will be the answer? When it comes to question 2, what will be the answer? Please follow what I've done here. Pause the video, follow what I've done, then solve this problem for me. Now let us say we remove this. Now let us say we remove this one here. Put what? CuSO4. Yes. Copper 2 sulfate. Do you understand? Let us say we use what? Copper 2 sulfate. What is the mass of copper 2 sulfate which is required to make 600 cm of 6.5 molar solution? So go ahead, follow what I've done here and solve this question. So let's go about question 2 and question 3 and question 4. Yes, let's go about question 3 and question 4. So let's explain here. So that if 2.0 exponential 20 atoms of an element have a mass of 0.03 gram, what is the atomic mass? What is the atomic mass? So how do we solve this problem? Please pay close attention. It's very easy. So therefore, they give us numbers of atoms, right? They say if 2.0 exponential 20 atoms of an element. So numbers of atoms were given to us. Numbers of atoms. They give it to be what? 2.0 exponential what? 20 atoms, right? Now, of an element have a mass. So they give us mass of the element. Mass of X, which is the element, what is 0.03 gram. Now remember, when we're talking about an element, you're talking about what? Atomic mass. You're asking what is the atomic mass of the element X. Atomic mass of what? Of X, which is what we are looking for, right? So which formula are we going to use in solving this problem? Which formula are we going to use? Now, they did say anything about mole, so mole is that of it, right? Now, yeah, they say something about mass. Mass of the element was given to us, right? So we want to use this one here. Now, mass over what? Molar mass. Is molar mass or molecular mass when is a molecule? Do you understand? But if it's an atom, it's not going to be atomic mass. Please differentiate between atomic mass and molecular mass. Atomic mass means an atom, that's why it's called atomic. Molecular mass means what? A molecule or compound, that's why it's called molecule. Do you understand? So we are going to use this guy here. It's going to be mass over what? Atomic mass, right? Is atomic what? Mass, right? Equals to. Now if you check very well, they gave us numbers of atoms. So numbers of atoms. So I'm going to use this guy here. So it's going to be numbers of atoms over what? The Avogadro's constant, which is 6.02 exponential 23, right? So remember, what are we looking for? Atomic mass. If you want make atomic mass the subject of formula, this, so we are using this equals to this. So making atomic mass the subject of formula now. What are we going to do? Let us use here. So going to be atomic mass equals to, right? This times this. So it will be mass times what? The Avogadro's constant, which is what? Over numbers of what? Of atoms. This is that numbers of atoms. Numbers of what? Of atom, right? So what we want to do here is to what? Place our values. So going to be atomic mass now. Atomic mass, right? Equals to atomic mass now equals to the mass that was given is what? 0.03 gram. 0.03, right? Times 6.02 exponential 23 over numbers of atoms is what? 2.0 exponential what? 20. So let's use our calculator here. 0.03 times 6.02 exponential 23 divided by 2.0 exponential 20. So the answer is 90.3. Remember, atomic mass, molecular mass, their unit is what? Is gram per mole. So we talk about molecular mass or atomic mass. Always remember that the unit is what? Is gram per mole. So it will be gram per what? Per mole. As easy as that, right? As easy as that. So What I want to do here, I want to change the values here. Now let us say you have 1.10, you have 19, right? If 1.10 is 19 atom of an element X have a mass, now let us say the mass is 0.068 gram. What is the atomic mass of X? So go ahead, solve this question from leave it at the comment section. Very, very important. Now, please try as much as possible to solve all the questions I'm giving to you to solve. Now, the best way to learn is by doing it. So I've solved the question here. It's left for you to solve for you now, so you can master it. Just so that is for this question here. Let's move over to the next question 4. Let's move over to question 4. So let's move to question 4. This is that what is the concentration of a solution containing 2.8 grams of sodium hydroxide in 100 cm³ of solution? How do we solve this problem? How do we solve this question here? Follow me closely here. Solution. The first thing we want to do here is to write out all the parameters. You say what is the concentration, right? So concentration, that's what you are looking for, which is called the molarity. Concentration which they say we should look for. Automatically, we are going to use this formula. Do you see that? Now, what concentration of a solution containing, now they gave us mass of NaOH is what? What is the mass? Mass is what? 2.8 gram, right? Now they gave us the volume. Now, volume is what? Is 100 cm³. Remember, I told that whenever you see cm³ in a question, you have to convert to dm³, right? How do you convert to dm³? By divide by 1000. If you divide something by 1000, you are going to get 0.1 dm³. Easy. So the next now is to bring out your formulas you are going to make use of. Of course, we are going to use concentration here. They are going to use mass, right? Because they give us mass. So it's going to be mass or molar mass equals what? Concentration times what? Volume. Can you see that? Volume. So what we want to do here is we'll calculate what the molar mass of this compound here, because you should make concentration the solid formula here. If you should make concentration the solid formula here, what are you going to get? Remember, here we have over 1, right? Cross multiply, going to be concentration times what? Volume equals to what? Times what? Molar mass equals to what? Mass. If you check it very well, right? Because when you cross multiply, you're trying to make this like solve the formula. So if you cross multiply, you're going to be this times molar mass equals to what? Mass, right? So if you would make what this constitutional solid formula here, which called concentration is equals to what? Mass over volume times what? Molar mass, right? Easy. Now we know the mass already, which is what? Is this. We know the volume already, which is what? Is this. Now let's calculate what? Molar mass. So molar mass of what? Of NaOH. Remember, here is not atomic mass now because it's a molecule. So whether it's called molar mass or molecular mass. You see that? So the atomic mass of sodium is what? Is 40 times 1 plus 16 times 1 plus 1 times 1. So the atomic mass of sodium should be 23. Here is 23. 23, yes, 23, right? So it will be 23 plus 16 plus 1 going to be 40 grams per mole. 23 plus 16 plus 1. 40 grams per mole. Do you see that? So now let's substitute what our values now. So here we're going to be concentration is equals to what? The mass is what? What is the mass now? Mass is what? 2.8 grams over. Now the volume is what? 0.1 dm³, right? So but you can ignore all this stuff here. So the molar mass is what? Is 40 grams per mole. So let's do the calculation here. 2.8 divided by, we have 0.1 times 40, we have 0.7. Now it can either be molarity, right there, This molarity also says that mole per dm cube. Don't forget mole per what? Dm cube. Now when I see capital letter M in chemistry, it means what? Molarity, which called mole per what? Dm cube. So it also be 0.7 mole per what? Dm cube. Just as easy as that. It's not difficult. So now let me give you one for you to try here. So now let us change the values. Now let us say we have 6.1 gram. Now let us say we have H2XO4. Now let us say we have what 200 cm cube. So go ahead, do this one for me. Leave it at the comment section. Solve it and what leave at the comment section. So let's look at our question 5 and what question 6. If you know that you can solve this question, you can go ahead, pause this video, then solve the question. Then once you are done, you can continue the video, then watch the answer if you get it or not. Just that is one of the way, that is one of the best way to learn. So now let's start with what question 5. What weight? Now in chemistry, when we talk about weight and mass are the same thing. Do you understand? Weight and mass are the same thing, but in physics, weight and mass are not the same. Do you understand? But in chemistry, we regard what weight and mass as the same. So it's like, what is the weight of NaCl sodium chloride is needed to make 2.0 dm cube of a 1.5 molarity solution? Do you understand? So question mark. They ask you what is the weight. So what is the mass? So mass of what? NaCl. Do what you have been asked. Now they gave me the volume. Very easy. Volume is already what? 2.0 dm cube, right? Molarity, which is the concentration. Concentration, of course, concentration is 1.5 molarity. Of course, we are going to use this guy and this one, right? So we are using what? We are using what? Mass over what? Molar mass equals what? Concentration times what? Volume, right? So let's look for the molar mass. Of course, you have to what? Make this guy solve formula here, right? So we have to what? Make mass the solve formula, because they say we should look for mass, right? We are looking for what? For mass. So if you should make mass the solve formula here, mass equals what? Concentration times volume times what? Molar mass, right? So what is molar mass of NaCl? Molar mass, so let's say molar mass of what? NaCl, because what? The atomic mass of sodium is what? Is 23. The atomic mass of chlorine is what? 35.5. So it's going to be 23 plus 35.5. 23 plus 35.5 going to be what? 58.5 gram per mole. Do you understand? So 58.5 gram per mole. So if you want to put your values here, you have 1.5 times volume is what? 2.0 times molar mass is what? 58.5. So what will be the answer? 1.5 times 2.0 times 58.5. Here we have about 175.5 gram. That is the word answer. As easy as that. Is not difficult. So what about if I should change this value now? If I should change it to what? Calcium carbonate, right? Or I change it to calcium carbonate and I change it to what? To 1. And I change it to what? 2.8 molarity. Go ahead and solve this one for me. Let me see what you can actually do, right? Let me see what you can do. Go ahead and solve that for me. Leave a word at the comment section. Leave a word at the comment section. Now, for those of you who have personal questions want to ask me, you can send me a DM through my WhatsApp number. Do you understand? I'm 100% available for me to be of help to you. Please, if you are watching to this point here, I really want to encourage you here. So I have a free guide for you when it comes to what? More concepts. I have a free guide for you. If you need that free guide, leave a comment section that you need the free guide. Then I will tell you how you can claim that free guide. For you to be able to watch this point, leave it at comment section. A free guide when it comes to what? Chemistry calculation, when it comes to more concepts and some other calculation aspects that you are going to see in exam. Leave at the comment section that you need that free guide. Then I will tell you how to go about it. Do you understand? As easy as that. But if this video is helpful, please always leave a comment section that this video is of helpful to you, and kindly share this video to other persons so that they can, if you have a group chat, share this video to that group chat so that other people can join and start learning too. Encourage them to subscribe. So go ahead, solve this one. Leave at the comment section. So let's go on. Let's tackle up question 6. 6. So calculate the numbers of atoms of chlorine present in 5.85 gram of sodium chloride. Okay, good. Now, sodium chloride. This is sodium chloride. They ask you what is the numbers of atoms of chlorine in sodium chloride. So look at something here. Therefore, you have to calculate the mass of molecule first. If you see this kind of question here, you have to calculate the mass of what molecule. So you need to calculate the numbers of molecule of this compound before you can calculate what the numbers of atoms of each of the elements present in that compound. Do you understand? So therefore, calculate the mass of molecule here. Numbers of what of molecule. First, you have to calculate it because here we have the mass of what of NaCl is what is 5.85 gram, right? So which one are we going to use? Of course, we have to use this and this. This that. So we have to use mass, what molar mass equals to what numbers of what of molecule. We are calculating numbers of molecule first, right? Over what 6.02 exponential what 22, which what is the Avogadro's what constant. This is that. So the goal here now, going by the molar mass of NaCl is 58.5 gram per mole, right? 58.5 gram per mole. So if I should what make this one is subject to formula here. You have numbers of what of molecule. Numbers of what of molecule equals to what mass times 6.02 exponential 23 over, right, the molar mass, right? So now let's impute what our values. Mass is what is 5.85 gram times the 6.02 exponential 23 over molar mass is what is 58.5. Yes, that is it. So going to be what 5.85 times 6.02 exponential 23 divided by 58.5. Here we have 6.02 exponential 22. Okay, so how do we now calculate the mass atom of chlorine in that molecule? Do you understand? So it's very easy. Now, if you look at what NaCl, how many atoms of chlorine do we have in NaCl? How many atoms of chlorine do we have here? We have one. Now, because we have one here, that is numbers of chlorine atom here. Calculate the numbers of atoms of chlorine in this one here. It's not going to be 1 times this one you are seeing here. Do you understand? So numbers of chlorine atoms. Now, because here we have 1, that would be 1 times 6.02 exponential what 22, which is also seen as 6.02 times 6 or 22. The same thing here, numbers as we they ask for what for sodium. Numbers of what Na atoms. You're going to be what 1 times 6.02 exponential 22. Do you see that 6.02 exponential 22 what atoms? You put atoms there. That is it. Now it's a compound that you have 2 or 3. You multiply by 2 or 3 depending on the numbers of atoms you have in that compound. Do you understand? As easy as that. So now let me leave you with one question. Now let's say this is let's say H2XO4 So they say calculate the mass of atom of hydrogen present in, now let us change to what, to 7.84 gram, right? So go ahead, answer this question 6 for me. Yes, and they say numbers of what, hydrogen. So you can say numbers of atom of hydrogen and what, oxygen. So do for hydrogen and oxygen for me and leave it at the comment section. Leave it at the comment section. So just do it for me, leave it at the comment section. So let me to what the next set of question 7 and what, question 8. So okay, so instead of me keep on solving a lot, now I want you to solve this one for me. So this is going to be your assignment. If you can be able to solve this problem here, then it means that you have clearly understood the concept of a mole concept, right? Or mole concept calculation. So these are ways you can use to solve mole concepts. So go ahead and solve this question here. But if you want a solution to this question, here, leave a comment section that I should give you a solution to this question. Then I will tell you how to get it. I want to send it to you just free. So leave a comment section that you need. Probably if you are done solving the question, then leave a comment section that I should give you what, or just say I need the answers to this question, to the assignment. Then I will send to you directly. I hope this video is helpful. Please kindly subscribe, like, and share this video to your friends, your classmates, and your every other person that you think that need this stuff. If you have a group chat, please send to your group chat. It's help to promote the channel, just and help to reach a broader audience. Just if you need a private class, always send me a DM if you need a private class. Thanks for watching. See you in my next video. See you in my next video.